Hello and welcome. Let's look at section 5.3 where we're working with separation of variables, kind of the last section in this particular unit. So what are we trying to do here? What does it mean to do separation of variables? So kind of my essential question is, let me get my pen going here. What does separation of variables mean? Hopefully we can answer that question today. And then, why is this important? Those are a couple of things that I'm going to try to point out to you today as we go through this lesson. So I don't know, if you want to write your questions over on the side, I tend to use this space more for just kind of outlining what we're going to do. So step one, what we're going to first start off by doing is to separate the variables, as indicated by the name of this lesson, right? And when I look over here to my question in dy dx equals x squared over y, I notice that there are two variables. And so this is sort of like an implicit problem with the two variables. So what we will do is bring the y up. So I'm going to use a little bit of algebra, multiply by y on each side, multiply by dx and bring it up. That is what's meant by separating the variables. Why would we do this? Well, it allows us then to integrate the y's with respect to y, dy, and the x's with respect to their x values, dx. Not too bad of integration. As integration goes, these are pretty easy. I'm going to, whoops, that should be a 3. I'm going to do my plus c just on the right-hand side. I could have it on both sides, but then I'd just subtract a c over and leave me one single constant over on the right side. Next, I want to multiply by 2. So I'd get what? 2/3 x cubed plus 2c. That's still just a constant, so we could just call it another c. You could keep track of these different c's by calling it like c sub 1 if you wanted to. And now, finally, what I'm going to do, let's keep up with our steps here. Step 2 was we definitely integrated both sides. And step 3, we are in the process of working on step 3 right now, solving for y. Right now I have y squared, so I'm going to take it that extra little step and say I'm going to square root both sides. So I would need that plus and minus. And then because of the application, I can decide whether it is a positive or a negative. And we'll see some examples of that as we go through. What we need is an initial point. And I think our next problem is the initial point. So what becomes here for step 4, if we have it, is finding C if given an initial point. What that initial point is a point that our curve must pass through. So much like when we were drawing in the solution curve on a slope field, we had to go through that point. So what we're trying to do is find the exact equation, then that precisely goes through that point. Okay? There's problem 1 done. Let's look at problem 2. Sine of x, y squared times y squared. So let's separate our variables. That's going to give me a 1 over y squared dy equals a sine x times dx. Next, I am going to rewrite and integrate. So I'm going to have the integral of y to the negative 2 dy, just to make it a little easier to integrate sine x dx. The integral of y to the negative 2 is the power rule. So I'm going to have negative y to the negative 1 equals negative cosine of x plus c. And now I think I'm going to multiply both sides by a negative. My goal here is I'm trying to get y by itself. Oh, I'm sorry, that would be a negative c, wouldn't it, if I'm multiplying both sides by a negative. However, a c is still a constant, so we really can just say that c absorbs the negative and just stays a c. If you want, you can call it c sub 1 because it would be a little bit different number than the previous c. And then I get 1 over y cosine of x plus c. And let's see, we could multiply. I want to solve for y. I want y equals, instead of 1 over y equals, I could multiply up both sides by y, couldn't I? And then divide by cosine of x. That is definitely the algebraic steps that accomplish that. Instead, I'm going to think of just flipping it over. So if I flip the left side over, I have to flip my right side over. And there was no initial condition given, so we can't find our c. And that's how to do that very first, or that second problem. Initial value, here we pick up the initial value. I can see that they said when y is 1, x is also 1. So we will be able to find out what c is in this particular problem. All right, so we want to separate our variables, step number 1. And looking at this one, I would say I should distribute that 2 through. So I'm going to say dy dx is equal to x squared y squared as my first step. Now let's separate variables. That would come over as a 1 over y squared. I'm going to write that as y, the negative 2 dy equals x squared dx. Now let's add integration on this. And certainly you could have, on that step above, just inserted these integral symbols. I did not, just so you saw my step progression in notes. Adding 1, that's going to give me a negative. Y to the negative 1 equals 1/3 x cubed plus some c. Let's pass the negative off to the other side. I'm going to rewrite this as 1 over y equals negative 1/3 x cubed plus c. And then, let's see, this will be not as easy to flip over. And it's going to get messy flipping it over. So I think at this point, I am going to choose to find my c. That way, when I want to solve for y, I'll have numbers in place and it'll make it just a little bit, I think, easier to follow the flow algebraically. So let me downsize this a little bit so I can continue working here. All right, so I'm going to pause for a moment and find my c using that initial pair. So 1 and 1, when x is 1, y is 1. And now substitute. And we get 1 equals negative 1/3 1 cubed plus c. But that's going to be 1 equals negative 1/3 plus c. Add a third over, I'm going to get 4/3 is the c value. Okay, so now we know c, and I'm going to come back and rewrite my equation then. I think I'll pick up a different color here. So my rewrite the equation with c involved. With c equal to 4/3. All right, so I'm going to pick up this line, 1 over y equals negative 1/3 x cubed plus 4/3. Oh, well, this comes together quite nicely now. Let's simplify this out, writing it rather than having two fractions. Let's merge this together. Negative x cubed plus 4, common denominator of 3. And then now take that trick and let's just flip things over. So y equals 3 over negative, well, I'm going to write 4 minus x cubed. Then I don't have to lead off with that negative. You'll see that sometimes in math textbooks that they prefer kind of that phrase rather than negative x cubed plus 4. That is all that was asked to do on that one, was solving for it. We did, and then over to the right, it wants us to draw in the slope field, or the solution curve. So drawing in the solution curve, going through, must pass through, shortcut that, 1, 1. So let's go locate 1, 1. Looks like it's right there. And I'm just going to follow. Looks like this goes steeply up. This has a zeroing and then passes somewhere down like that. I would say that's my curve. All right, next. On the back side, looks like we have two more questions. It says use the differential equation to answer the following. dy dx equals 2x over y. Fill in the slopes field, write the equation of the tangent line, find the particular solution. This looks like it was probably a free response question on the AP or very similar to one. To fill in the slope field, I'm just going to start using some numbers in my head. If I chose 0, 0, I would have an undefined slope. Now, for undefined slopes, we could draw in a vertical. Often the AP just doesn't even draw in anything, but if you wanted to undefined, we know to be a vertical asymptote. Actually, anytime y is equal to 0, we get undefined slope, don't we? Which means that all along this vertical line, the y-axis, we are going to have these vertical. Oh, hey, what am I doing? Y is equal to 0 on the x-axis. So there we go. All right. Probably more standard on the AP is just to leave it open and not put any slopes in there. All right. Now I'm going to go to 1, 0. No, I'm not. I'm going to go to 1, 1, and that would give me a slope of 2. I'm going to go to 2, 1. That would give me a slope of 4, so draw it in a little steeper. I'm going to go to 2, 2. That would give me 4 divided by 2, which is 2. And 1, 2. I'd have 2 divided by 2, which gives me a slope of 1. Should be a little flatter than the previous one, and so on. So you could go through and do the rest of these. I don't think you want to sit and listen to me doing them. Slope of 2, but it's negative. And you could fill in the rest of those. I think you guys got that down. All right, the next thing it says, write the equation of the tangent line at the point 2, 1. Those are kind of the two pieces of information. Well, equation of the tangent line should be easy by this point. It means we need a slope. Where do we get the slope? From the given derivative that started the problem. dy dx equals 2x over y. I need to evaluate this at the point 2, 1. Please practice this notation. It'll be valuable when you come to the AP exam because they can very easily see what you're up to. Oh, there I can see that she's entering a point here. And I get a slope of 1. Now I can go and write my equation of the tangent line. Y minus 1 equals the slope, x minus 2. Very nice. Probably 2 points on the AP exam. So I probably would see 2 points from drawing out the slope field, 2 points for the equation of the tangent line. These slopes were 0 on here. Most likely, they probably dedicated 1 point to coming up with the horizontal and vertical slopes. And then the other point was probably assessed using like, okay, this was supposed to be steeper than that. Did they draw it that way? And just see were the positive slopes positive and a negative region, or negative slopes shown with a negative dash there. So we're probably up to 4 points so far. Now comes the biggie. On the free response questions, finding the particular solution has a lot of points attached, mainly because I'm trying to get back to the very first screen. They assess a point for separating variables. They assess 2 points typically for integration. The integral of each side is typically given a point. And then they usually devote a point to finding C, and then they devote a point for coming in with a solution. So right there, I easily added up to 5 points. And on this one, I guess 5 would work because 4 plus 4 points plus 5, I'm sorry, 2 and 2 gives us 4. That gives us 9 points. And every free response question on the AP exam is worth 9 points. All right, now we're going to take the equation dy dx, which was equal to 2x over y, and solve it out. I'm going to multiply up by y, multiply by dy, 2x dx. I tend to leave my constants on the right side because I know what I'm trying to do at the end is get y equals, so y move that number over to the left. Integration, I'm going to show my integration just by throwing that in. Now I'm going to have 1/2 y squared, and the integral of the right is going to be 2x squared divided by the new power, which means those cancel. So I get 1/2 y squared equals x squared plus c. And now just keep solving and bringing it into y equals. So I'm going to multiply both sides by 2. I get y squared equals 2x squared plus 2c. Not necessary, just continue calling it c. Let it absorb that multiplication of 2. There was an initial condition of 2, 1. So I'm going to stop for a moment and find c. That finding c is the location 2, 1. And plugging things in, I'd have 1 squared is 1, 2 squared is 4, 4 times 2 is 8, and it appears that my c is coming out to be -7. Now I'm going to go into the rewrite stage, and that's going to look like y squared plus 2x squared. I'm looking right back there. And then the c now gets updated with -7. They ask for the particular solution. I need to have this as a y equals plus or minus square root. There should have been an equal sign there, shouldn't there? Plus or minus 2x squared minus 7. This is not a function yet. Because of the plus minus, I would end up with like 2 branches of a parabola here. And to get this knocked down to just 1, I look back at the initial condition, 2, 1. This indicates to me that I need to have a positive y value. The only way to get y equal to a positive is to remove the plus minus and just stick with the positive, which I really don't need anything there. And this should be our solution. Now, could I check this answer? For sure. Let's go 2, plug in our 2 there, subtract 1. This should equal, or subtract 7, this should equal 1. I get 4. 4 times 2 is 8. 8 minus 7 is square root 1. And yes, indeed, it checks out. We get a y value of 1. So we know we've done it right. All right, one last problem. Let's see if we can keep this under 25 would be my goal here. First thing says sketch the particular solution, and we want to be sure that we're going through the point 0, 1. 0, -1 is right there. Looks to me like this heads off. Whoops, don't draw arrows, it's so tempting. Bring it to the edge. Drop this down and bring it to the edge. Maybe I should have, I think I really should come through there. Then I'd be over on this side. I like that better. Find the particular solution. Okay, that's separation of variables. So I am going to divide by this. I'll have 1 over y plus 2 dy equals ex dx. We want to integrate both sides, so add an integral symbol. And now let's integrate. Integration on the right is easy. E to the x is e to the x. But what about the one on the left? It's not too bad, but you may want to use a u substitution. I'm going to just slide this stuff over because I want my u substitution to be handled right here. U sub, mainly for the y case. So I'm going to let u equal y plus 2. Then I can see that du is equal to dy. Well, that's easy then. And let's grab this. So I get the integral of 1 over u. dy is the same thing as du. On the right side, easy, I'm going to go ahead and process out that integration. 1 over u is natural log absolute value u, which is equal to e to the x plus c. And now in order to get rid of natural log, oh heavens, let's switch back to our y value there. I don't want u's in this one. Okay, now solve for y. So let's introduce e to both sides. At some point along the game here, I do need to get my c value, don't I? I was just thinking of this. This looks quite messy over here. So I think I'm going to take a step back and find C at this particular moment. I'm going to find C when I was left with this little bit nicer equation. And would we have the ordered pair 0, -1? So I put in -1 for, I'm sorry, where did I come up with C there? +2. Put in -1 for y. I'd have natural log absolute value -1 plus 2. That's going to be 1. I can evaluate that. E to the 0 plus c. Okay, now let's evaluate. And we're going to have natural log of 1. Don't really need the absolute value there because 1 is already positive. Natural log of 1 says e to some power equals 1. Well, that would be the 0 power. Solving for c, we come in with -1. Okay, sweet. Let's keep moving on. Let's rewrite with our c. And that gives me an equation. I'm going to modify off of this one. Natural log absolute value y plus 2 equals e to the x minus 1. Now, the only choice I have really is to push through and get rid of the natural log, which I'm going to introduce the e on that. And that's going to leave me a y plus 2. I know that this expression will be positive, so I'm going to let my absolute values disappear, and I'll have e to the x minus 1. Not a real fantastic answer there. Y equals e to the x minus 1 minus 2. This would be an acceptable answer. I think we'll just leave it there because it's really not going to simplify nicely at all. All right, that covers that. Homework for the lesson is 1 through, is it 10 or 9? I just can't quite remember. 1 through 10. Okay, so you got a lot of separation of variables. Practice this because this is usually every year a question on the AP test, and they're often worth 5 to 6 points. So you want to be able to do these and do them quickly. This year, anything goes, but I'm anticipating you'll probably still see this. So practice those and upload them, please, to Schoology so I can see your work. If you can put it in a PDF form with the multiple pages, the front and back, that would be ideal. If you cannot, well, then why don't you lay both pages flat, try to take one picture of all of it and upload that. Thank you guys. Have a wonderful day.